different interest rates and methods of compounding, it is sometimes difficult for a consumer to compare two different options. For example, would you prefer an investment earning 8.75% annual interest compounded quarterly, or one earning 8.7% compounded monthly? Okay, you got to decide what you want here. All right, now we're going to look at example 6. Ursula invests $2,000 with Crab Key Bank at 5.15% annual interest compounded quarterly. What is the equivalent APY? Now what we'll do, we'll solve it first, then we'll talk about what really APY is. All right? So what I suggest you do, let X equal the equivalent APY. And I'll definitely write that down. This means your A will be 2,000 times 1 plus X. Because remember, if you think back to our equation, A is equal to 1 plus R over K to the KT power, right? So what we can say then is 2,000 times 1 plus X will be equal to 2,000 times 1 plus 0.0515 over what? Over quarterly, so it's 4 to the 4 by 1 power. What happens to the 2,000? The 2,000s will cancel out. So really, we'll be left with 1 plus X equals 1 plus 0.0515 over 4 to the 4th power. How would I solve for X? I subtract 1. Now we're going to put that into our calculator. We get about 0.0525 or 5.25% APY. So what this is, an investment with 5.15% annual interest compounded monthly is the same as an investment where you're compounded yearly at 5.25%. Does that make sense? That's just telling you the same thing. So we're trying to get everything on the same playing field. All the different compounded monthly, weekly, daily, whatever. If we can change it into an APY, we can all compare them at the same thing. You follow that? That's what we're trying to do here. Why don't you all work on B? All right, now looking at B. Caden invests $3,000 with Key Bank at 6% annual interest compounded monthly. What's the equivalent APY? So 3,000 times 1 plus X will equal 3,000 times 1 plus 0.06 over 12 to the 12th power. 3,000s go away, which means X will equal 1 plus 0.06 over 12 to the 12th power minus 1. So you get about 0.0617. All right, so 6% annual interest compounded monthly, would be the same as 6.17% annual interest compounded yearly. Now you should notice, does the amount of money I invested matter here? No. The amount of money doesn't matter because you're going to divide by that anyway. So we can assume that P is equal to 1 when comparing investments. Now, back to that original question at the top of this page. Which investment should Mr. Grote go for? One that pays 8.75% compounded quarterly, or another that pays 8.7% compounded monthly? So the 8.75% is compounded less, but it's a bigger percent. 8.7% is compounded more, but it's less of a percent. So again, 1 plus x is equal to 1 plus 0.0875 over 4 to the 4th power. Actually, I want to change this instead of x. We're going to call it rate 1. So R1. And that means 1 plus R2, 1 plus 0.087 over 12 to the 12th power. Yes. 0.0875 comes from here.
Oh, that's R2.
Yeah. R2 is 0.087. So the mathematics behind it, 1 plus 0.0875 divided by 4, caret 4 minus 1, is about 0.0904. Okay? And then if we do the next one, at 0.0906. So which investment should I go for? 8.7% compounded monthly. The more you compound, the more money you'll get. Sometimes, but it really depends on the percent. It really all depends on what percent. I mean, that's pretty close, isn't it? Not necessarily. You have to be careful. I mean, if you look at the other one has a higher percent, but it's compounded less. Okay. All right. Are there any questions on this right now? Future value. So we're talking about annuities. So far, in all the investment situations, we've considered the investor has made a single lump sum deposit. But suppose an investor makes regular deposits monthly, quarterly, or yearly, the same amount each time. This would be considered an annuity situation. An annuity is a sequence of equal periodic payments. The annuity is ordinary if deposits are made at the end of each period at the same time the interest is posted in the account. In this class, we'll only consider annuities that are ordinary. Now, think about this. Annuities. You guys ever heard of a TSA? A tax-sheltered annuity? That's basically a retirement account. Same with the Roth IRA. There'd be a tax-sheltered annuity. Right? That's what we're going to be talking about here. Now, let's consider an example. Suppose Sarah makes quarterly $500 payments at the end of each quarter into a retirement account that pays 8% interest compounded quarterly. How much will be in Sarah's account at the end of the first year? Please notice the pattern. Now, at the end of the first quarter, she puts in $500. No interest is on that $500. She just puts in the $500. Now, at the end of the second quarter, she's getting interest on this first $500 and also adding in another $500. Now, if you remember right, she's getting 8% interest compounded quarterly. That means we've got to take our 8% divided by 4, right? Which is 2%. That's where this 1.02 comes from. Now, at the end of the third quarter, again, she's getting interest on the stuff that she put in first at the end of the first quarter. She's getting new interest on the stuff she put at the end of the second quarter, and she's also putting in $500 extra. $1,530.20. Now, at the end of the year, she's still getting interest on the stuff she put in the first quarter, getting interest again on the stuff she put in the second quarter, getting new interest on the stuff she put in the third quarter, and then she's also putting in $500 extra. So she got, at the end of the year, she's got $2,060.80 in her account. How much did she actually put into her account out of her own money? $2,000. So she's put in, she got back in interest about $60.80. Make sense? That's what we're doing there. Now, the total value of the investment return from an annuity consists of all the periodic payments together with all the interest. This value is called the future value of the annuity because it is typically calculated when projecting into the future. Now, here is our formula for future value. The future value, signified by FV, will be R, which is our regular payments, 1 plus I. Now, this I and this I mean the same exact thing. They will both be the rate as a decimal divided by K, and N is K times T. How many payments you are making times the amount of time. So how many total payments you're making into this annuity. So we look at this in example 8. At the end of each quarter year, Emily makes a $500 payment into the Lanigan Mutual Fund. If her investment earned 7.88% annual interest compounded quarterly, what will be the value of Emily's annuity in 20 years? So we're looking for future value. That will be our $500 times 1 plus R over K. How many total payments am I making in the 20 years? I'm making 80 payments in the 20 years. Minus 1. All of that over 0.0788 divided by 4. Now, when you put these in your calculator, here's what I suggest. I suggest doing the numerator first. 1 plus 0.0788 divided by 4. Carry that to the 80th power. Subtract 1. Let's get this. Divide this by parentheses 0.0788 divided by 4. And you get this. Multiply by 500. And you get your answer of $95,483.39.
My first number comes up.
What's that? Now, don't try and put too much into your calculator right away. Do it step by step to make it easier for yourselves. Now, if you think about this, how much money does Emily put in per year? $2,000, right? That's how much money Emily puts in every year. How much over the life of the annuity did she put in of her own money? $40,000. So she only put in $40,000. How much money did she make back in interest? $55,000 in interest. I'd say it's pretty good, right? Pretty good return on your money. Okay. Now, why don't you all try B? All right, so our payment every quarter into the mutual fund is $1,000. 0.07 divided by 4 to the 24th power because you're making 24 payments. So what we're doing Again, 1 plus 0.07 divided by 4. Raise that to the 24th power. Minus 1. Divide that by 0.07 divided by 4. Multiply that by 1,000. $29,511.02. So let's think about it like this. Who's putting in less money per month? Gina or Emily? Or every quarter? Emily's putting less money per month or per quarter. She's getting a little bit more interest, that's fine, but she's leaving it in there longer. So you got to think about it like this. When you guys first get your first career job, like after college or army, wherever you're going to go, I would suggest, highly suggest, that you start an IRA, retirement account, or a tax sheltered annuity, or a 401k, because the longer you leave the money in there, the more the interest works for you. Okay, you don't want to start it 10 years before retirement. That's not going to get you anything. But if you start it when right out of college, you start it, the more money you'll make in the long run. Now, let's look at loans and mortgages present value. Okay, talked about future value, now let's talk about present value. An annuity is a sequence of equal period payments. The net amount of money put into an annuity is its present value. The net amount returned from the annuity is its future value. The periodic and equal payments on a loan or mortgage actually constitute an annuity. But how does the bank determine what the periodic payment should be? It considers what would happen to the present value of an investment with interest compounding over the term of the loan and compares the result to the future value of the loan repayment annuity. Now, there's a whole bunch of different mathematics here that gets us down to the equation. A lot of times, the formula is basically the same thing. I is still going to be the rate divided by how many times you're compounding, or how many payments you're putting in. The N is still going to be the number of payments that you're making. Okay, all that stuff's still the same. So the present value of an annuity will be our payment times 1 minus 1 plus I to the negative n power divided by I. So it's pretty close to what we were just working with. Now, again, the annual interest rate on consumer loans is considered APR, the annual percentage rate. APY for the lender is higher than the APR. Now let's look at example 9. Charlie just purchased a new car for $28,395. What are the monthly payments for a 5-year loan with $11,165 down if the annual interest rate of the APR is 3.54%? Okay? So, what is the present value of the loan? How much is Charlie taking out of the bank? How much is he borrowing? He's borrowing $17,230. How did you get that, Nathan?
The price you bought it for and subtracted the down payment.
Good. This is how much you bought it for. This is the down payment. That will equal R1 minus 1 plus 0.0354 divided by 12. How many payments is he making? How many payments is Charlie making over the life of the loan? He is making 60 payments, 12 payments a year for 5 years, 60 payments. So you want to put negative 60 there, and then 0.0354 divided by 12. Now here's how I would compute this answer. I'm going to figure out all that stuff on the right side, okay, in the calculator. So I'm going to take parentheses 1 minus parentheses 1 plus 0.0354 divided by 12. Carry that to the negative 60th power. Divide that by 0.0354 divided by 12. And you get this.
Why is it a negative 60?
Maybe I put that wrong. Oh, that's why. I forgot a decimal point in the top. So you should get 54.92. Well, of course, she also did forget a parenthesis, though, that I had that before. All right. So you should get this. Now, what I want you to do, you want to take 17,230. We want to divide it by this answer, right? So what you could take is 17,230 divided by the answer. You get 313.75. Second negative.
So why is it negative 60?
What's that?
Why is it negative 60?
Because in the formula, it's a negative m. That's why. Now, if you go to say cars.com and we look at our auto loan calculator, maybe eventually, and we go to the vehicle price. How much the vehicle costs? $28,395. Down payment of $11,165. 3.54% interest for 60 months. Here's our answer at 313.75. Now that does not include sales tax. That's something totally different. Yeah.
This stuff's gonna be on your test.
No. On the next test, but not this one we're having Friday. Okay. Now I'd like you to find out how much Kevin is paying per month. Go ahead. Kevin just purchased a new light-duty pickup truck for $18,500. What are the monthly payments for a 4-year loan with a $2,000 down payment if the APR is 2.9%? How much is the loan worth? The loan is worth $16,500.
No.
This is what we're going to have, right? Negative 48 because it's 4 years, 12 payments a year. So take 1 minus, parentheses 1 plus 0.029. We're going to take 16,500 divided by our answer. 364.49. All right, are there any questions at all on any of the examples we went over today?
No, sir.